Hi, everybody. Um, so I'm gonna be giving a talk just on more something a bit more geeky that excites me, which is first of all, how do you do network operations in the modern age, and what tools you use for that. So um, I prepared this talk very rushed, so I'm a whiteboard type of person. So I wish I had a whiteboard to like speak a bit more openly. But in a nutshell, first of all, there's this new buzzword called containers, and it's been evolving very quickly. And containers pretty much are lightweight, standalone, executable packages of software that you can package and then deploy across your network. And that delves into the realm of infrastructure as a service. So the kind of software packages that you can use really your network functions. So you can have a virtual router, you can have websites, you can have a load balancer, for instance, and you can package that and deploy it across your network. And what makes that exciting is that you can literally deploy it on any compute or any server that you have, whether it's a virtual machine or a server running on a bare metal. So as you can see there, Docker is pretty much taken over the world of containerization, and you'd have your infrastructure with an operating system, and on top of that operating system, you'd have your Docker engine, which spins up your different applications. One of the things as well is that there's tools that have been created, cloud tools such as Kubernetes, which allows you to spin up your containers directly the same way that you would spin up a virtual machine on an hypervisor. So I kind of wanted to do a demo with what I have running on my laptop, but I think it's going to be a bit of a mission to plug and unplug. But this is just a typical example of the things that you can do. One of the things that you do when you in your network operations is you want to have redundancy and resiliency at times. And what this brings about is the concept of distributed microservices architecture, where you can actually now spin up a cluster of your application, and you can have a load balancer in front of that cluster, and then you can take that cluster and distribute it across your network. So each you can have nodes on your network that's running a cluster of that app. So each node may have multiple instances of the same application. And that has the advantage that if the application goes down, then you have other applications that kick in with your load balancer and keep your operations going. One of the things that this could be used for instance, is you could have an application that connects to a database and you want to keep it highly available, or you could have some form of authentication. There are systems such as Vault, for instance, and you want to keep it highly available. And this is one of the good use cases for it. So that's really in a nutshell. I just wanted to speak about containerizing applications and spinning them up across your network. And if anyone has questions, you're welcome to ask. All right.
Maybe you can tell us a little bit about how you've used this at CCOM and how it's changed how you run your network.
Okay. So I'll give two examples. The one example is we literally at the moment, within the next week, we're spinning up. We started using our trouble ticketing system, and we ran it on one node. And what had happened was that the demand was low at the time, and we envisaged that it would just be for a single team to use, and it like grew like out of control, and the whole company is using it, and our customers are using it as well. So we went from having a few concurrent sessions, like less than 100 sessions a day, to thousands of concurrent sessions a day. So running that application on a single node became like a problem, and it became a mission critical application that needed to be up 100% of the time. We also have teams that operate in different regions across the world. So we needed to make sure that when they access the application, that it's the latency is low. And also when we have like a, when there's an outage across the network, that we can reroute them to the closest, intelligently reroute them to the closest instance of that application. Therefore, we ended up building a cluster and distributing it across 3 regions: Nairobi, Johannesburg, as well as in Durban. And so that kind of takes care of our teams being able to log in and being served from the region that's closest to them. Other than that, we also have databases that store the data, and it's sheer amounts of data. So we also distributed that database into a highly available cluster, and also distributed across the network. But to keep the database synchronized, we use the cluster, and each app speaks directly to the database. We have a file system that's also highly available and distributed, and that is kept synchronized using rsync. Hi.
My name is Sam from Internet Solutions.
Yes.
And my only question is, looking at that architecture, they seem to be sharing the same kernel.
Yes. Well, okay.
Containerization. Yeah? With regards to the change in cybersecurity landscape, how are you going to address security issues in a container? Are the demerits versus the advantages, do they outweigh each other?
Well, from a security point of view, I find it to be more secure, in the sense that you, let's say, if you have an application that's running in front of a load balancer. So when I build a cluster, I always put a load balancer in front of it. So my load balancer, I only allow specific ports. Usually, let's say if it's a web application, port 80. All the other ports are closed. So accessing anything in my network will always be through the load balancer. So from a security point of view, I only have that. And the rest of the network actually, the actual applications themselves sit on the network. One of the things that we do as well is we use public-private key authentication. So the applications themselves, you cannot SSH into them. There's a central management interface that actually takes care of accessing the application. So therefore, there's no warm body access into it. And we build it in a very dynamic way, such that there's in Docker, you have Docker Compose, which is like a file, a YAML file that you can write your configuration script. And that takes care of spinning up the application. Therefore, nobody actually even goes and literally logs onto these devices. And with automated, with the failover mechanisms that we have, the self-healing, is that if one instance goes down, another one spins up automatically. So the one area is the database, but we keep that behind. Pretty much one area that has stateful information. It's stateless mostly, and the stateful information is hosted on the databases, which stays locked behind the network. So for me, the disadvantage is I'm still exploring whether, because these are also very small workloads, but they use the resources on the host operating system. And I'm exploring whether that would be a limitation, considering it's virtual, or if it actually does use the resources that are available to it.
Hi, I'm Rishabh Phonik.
Hi.
Yes, I had a very little experience with Docker, and I actually had quite a bad experience with networking with Docker, maybe because I'm not so much of a networking guy. It was kind of a pain for me, for example, to assign public IP addresses to Docker instances, and forgot about IPv6. Couldn't do that. Especially if you're running a Linux box where there is some level of abstraction in between the layers of the network. I'm wondering if you had the same issues, or maybe there are things, perhaps, I don't know, Kubernetes that helps mitigate those issues. And also maybe a second question, what else can you do with Docker? Can you do some software-defined type of networking, running switches and routers and things like that?
Can you repeat your question?
The second one.
Mm-hmm.
What else can you do with Docker? Can you run some software-defined networking applications? I don't know, maybe do some switching and routing on Docker. Is that possible?
Yes, it is possible. I have. Thanks, Watson. I have investigated that, but I haven't really gotten into it. But in a nutshell, if you go to Docker Hub, you have the image registry, and they have images for everything. So you can do quite a lot with it. And for me, what's exciting is that I can literally prototype, if I want to spin up an application, or if I want to build a network, I can prototype it on my machine. And then spin it up on my machine and deploy it into production with the exact same configuration. Because one of the advantages of Docker is that because you hosting, it's independent of the operating system. And once you have the configuration right, you can deploy it anywhere. So there's quite a few applications. I just want to see if I can type this in. Good. Maybe I can show you. This is literally me logging onto my Raspberry Pi at home. And I have the same thing running on Vagrant, which is pretty much a miniaturized version of VirtualBox. So I have a Django application that I'm running off of my Raspberry Pi. And as you can see on the right there, there's the ports. So as you can see, I don't even assign IP addresses to it. And what I do is I work with the ports. So I assign ports dynamically, and each instance is identified by the port. So I have a load balancer here, and the configuration of what I do lies in my load balancer. As you can see, I have HA proxy running, and I can maybe see if I can show you the configuration of the load balancer. I've also been playing around with HA proxy as a load balancer, and it's really great. It's easy to use, and like there's all these settings, but the interesting one is, I have port 80, so I receive all my traffic on port 80, and then I balance it across these three instances on ports on between 8,000 and 8,002. And if you look at my previous screen, you'll see that my configuration works in that manner. And one of the things that I can do is to show you how easy it is to use is I've had some, let me do this. So this is the application that's running, and I have some commands that I pre-entered here, where let me first show you once again. So this is the network as it is. All right, so these are the three applications that are running, and so from port. So as you can see, port 8000, 8001, and 8002 are rerouted all to port 8000 inside the load balancer. So there's port forwarding between those ports. And on my HA proxy, there's port 80 that's listening there. And I'm going to take down, the one application. Whoopsie. Sorry, not that one. I'm just going to stop this application. It's taking a bit of a while. While that's happening, you'll see that this application would still be running. Oops, not available. Let's try that. There we go. So it's still running, and I'm going to take down the next one. And still running. And I will take down the last one, and you'll see that it will stop running. And I'll just show you the images that I have. Okay. As you can see, these three, the applications are all down. My proxy is still up, and my databases are still up. And you see service is not available because the load balance has nothing to redirect traffic to. And if I bring up one application, service is restored. Give it a minute. Okay, so there it is. And you'll see that. And the service that I've restored, 01, that's sitting on port 8000. And the other two apps are still down. So in other words, you know, instead of relying on one node, you actually have multiple nodes that you can have. And so that's quite an advantage. And as you can see, these are just commands that are run to spin it up. So from a network operation point of view, you can totally automate everything, and your nodes could go down, and you can have ways to monitor that the nodes have gone down, and then you can have a command that automatically spins it up once if you can't ping it or something like that. So that's the concept of self-healing. And, you know, it's very, you know, high level, but from a network operation point of view, it's quite powerful. All right.